Welcome to Physics with Mr. Brazil. Today we're looking at unbalanced forces being applied to a wheel, so we're going to have to use torque equations. So in this case, we have a wheel within a wheel, or two round objects that are meeting at some sort of interface. So we have one wheel here in the middle that's in dark blue, and a lighter wheel on the outside. So this could be your car rim, bicycle rim, and then the wheel on the outside, and some force 15 newtons being applied tangent to the curve. Okay, so these forces are tangent to the curve. So that's even for the 25 newtons. Now, here's the cool thing about this. If you take a line and go down from the center, that would be the radius, and that radius would be 90 degrees to that tangent curve. And that would also be true for the 25 Newton force. So you can draw a radii, and that would be 90 degrees. So sine theta is 90. Make sure that you write a little dot and an arc and show the direction of your twist or your rotation. So my thumb would go into that dot, my fingers would curl with the arrow. That would be a negative torque going into the paper, and my thumb coming out of the screen and fingers curling counterclockwise, that's a positive torque. Set up your torque equation, the net torque. So for 1, it's going to be -1. So 1 is the R10 meters, so that's the 25 newtons. My thumb goes into the screen, my fingers go with the 25, that's a negative torque. While the 15, that's the R2, the radius 5 meters. My thumb would come out of the middle, and my fingers would curl in the direction of the 15 newtons. So that's a positive. So torque 2 is positive. So put in our torque equation, force times radius, sine 90, so that's 1. In this case, we don't know whether it's spinning or if it's where it's rotating or if it's static. So let's plug our values in and see if it equals 0. So we're going to put the 25 newtons times the 10 meters and the 15 newtons times the 5 meters to get a negative 180 newton meter. So if it's negative, that means that the overall rotation will be towards the center into the screen and 180 newton meters. That's kind of how that's figured out. And if you're not understanding this, slow down the video, pause it, look at the math. Let's look at another one. This one I've seen before where they put little angles next to the tangent forces. Don't worry about those. They're just there, whatever that means. Again, you go from the radius and you go right to, let's say, the 8.3, and you make a 90 degree. The 11.2, make a 90 degree. Again, also the same thing for the 5.7. You go from the center and you go to that 5.7. You can make a 90 degree from the radius, R1. And so don't let this confuse you. Set up your net torques because everything is still tangent. Make perpendiculars. So tau 11.2. My thumb is going into the screen, my fingers curl clockwise, so negative. Same thing for the 8.3, except for the 5.7, that torque, my thumb's going to come out of the screen and curl counterclockwise. If you need to, pause the video and put your right hand out, and you can get an idea of how this all works, the torque in the negative and positive direction. Okay, now, in this case, again, this time I put the 90s, not needed, but it's all 90 degrees. We don't worry about these angles unless there's something else, some other force coming parallel to the axle somehow. I don't know. But other than that, plug in your values, use your calculator, and this is going to have a negative 3.3 Newton meter. So the direction will be clockwise. It's a negative sign. It's going towards the screen. Again, pause the video, play with the math, and keep practicing your physics. Bye.